Hello, we're going to do 10.4 start 10.4 today. This is a class I have scheduled as Monday, April 13th. The test is still active. Some of you maybe are still working on it because it's due Tuesday night, but have to keep moving on. So we took Friday off, do the test, and Monday there's new stuff. So this is the class for Monday 4/13. Okay, so we're going to start a new statistical test today. We've done approximations for one proportion and then talked about splitting into two groups and comparing the proportion between the two groups. So this is something else called the chi-square test. So this is written out as CHI squared. Okay, so CHI, that's the Greek letter chi. It's not chi. However much your intuition might be telling you. It's Greek chi. CH is a hard C, like in school or chaos, or basically any CH word that came from Greek. So stuff like chimera and stuff like that. So chaos, hard C, school, hard C. This is chi squared, not chi squared. All right, so what is this one for? This test is specifically for comparing two categorical questions. So categorical, that's like a multiple choice type question. Multiple choice, yes, no type questions, etc. In other words, not quantitative, not a number answer. Okay. The first half of this class with probability, pretty much any time we did anything, there was a number generated and we could find the mean and find the standard deviation and stuff like that. Lately, we've only been dealing with categorical questions where for each subject that you are analyzing, like you record a piece of information and it's not a number. It's a category, like who did they vote for? Like what species are they? What color are they? Did they succeed or fail in some test? It's always like a multiple choice type piece of information you record, not a number. And so in the test today, there's going to be two such pieces you record. And this is similar to what we did with splitting into two groups, right? Like maybe we split into the group that voted or decided who they were going to vote for a long time ago, and the group that decided who they were going to vote for recently. And within those two groups, which group was more likely to have ended up voting for Trump, for example. So that was like something that we did, or for example, like maybe we could split into two groups, one of those groups are children that attended preschool, and the other group is children who didn't attend preschool. And so we want to know which group is more likely to end up going to college in the end, stuff like that. So there's two pieces of information we record for each subject. The piece of information that you use to split them into groups, and then the second thing that you compare the proportion for. So like the first piece of information, when did you decide who you're going to vote for? And then who did you actually vote for? So chi-squared is another way of testing when you have two pieces of categorical information, but where there's more than two answers. So in all of the examples I just gave you, there's really only two answers. There's the two answers you use to split into your groups. And then the other question, there's sort of like two answers, like, are you in the group, like did you vote for Trump or did you not? Are you a success for the proportion we're looking for, or are you not? So we really only pay attention to two answers to split into two groups, two answers to say, are you part of the proportion that we're checking? Chi-squared allows for more than just two answers. So I better get into an example just so you can see what I'm talking about. So example, and actually my first example also just has 2 answers to keep things simple, but next day we'll have some examples where there's more than 2 answers. So a small farm plants 2 kinds of squash, acorn squash and butternut squash. Some of the plants end up dying of a fungus, die from a fungus. So I don't know how many of you have ever tried growing squash before, but there's this like powdery white mildew fungus that they tend to catch, and it seems to hit every kind of squash that I plant. Zucchini, pumpkins, like any kind of squash that I plant, there's a good chance that it gets this fungus. Depends on how much it rains, I guess. So we are given a bunch of information. So I'm going to put that in a little table here. So every squash plant is either an acorn squash or a butternut squash. And every squash plant either dies from the fungus or it survives. And then I'm going to have the totals off to the side. Okay, so how many plants do we have? Well, we have 273 acorn squash plants and 230 butternut squash plants. That gives us a total of 503 plants altogether. How many of the acorn squash die and how many survive? I'm actually not going to tell you that right now. That's going to come later. What I am going to tell you is out of the 503 total, 187 died and 316 survived. Okay, so what we want to do next is think about what numbers we expect in the middle of this table. Now, it could be any kind of, there's a lot of different numbers that could be in the middle of this table and have the totals come out correct. So what I want to do is ask what numbers do we expect in this table if the 2 variables are independent. Okay, so we have 2 variables. Each squash plant is either acorn or butternut. That's the first thing that we would record for a particular squash plant. And they either died from the fungus or survived the fungus. That's the second piece of information we record. So those are the 2 variables. What kind of squash are you? Did you survive the fungus? If these 2 variables are independent, it means that it doesn't matter what type of squash you are, you sort of had an equal chance of surviving the fungus. If they're not independent, then one of the varieties of squash would be more resistant to the fungus and the other would be more vulnerable. So let me write that down. If, so independent, what does that mean? Independent, that would mean both varieties of squash are equally likely to survive the fungus, and not independent, which we'll call an association, so that's sort of the opposite of independent, means the variables are somehow connected together. That means that one variety is more likely to survive than the other. Okay. So if the 2 variables were independent, what numbers would you expect in this table? So I've talked enough for this video. Let's compute that other stuff in a second video. So I'll stop here.